And now it's time for the latest exciting episode of Doz's Television Workshop.
Hello and welcome back to Doz's Television Workshop, where today we're looking at yet another Linn Karik that's gone dead. Let's get into it. You know what my suspicions will be if you're a follower of this channel, and it will be the dreaded brilliant power supply. Will this one be salvageable, or will it be ruined? 4 M3 screws in the bottom in traditional Linn fashion. This one assembled by J. McAnally. That's encouraging. There's a nut in the bottom. That may mean it's either got a round brilliant power supply or a transformer. Because the round ones are usually salvageable. Oh, here we go. Come on. We've got a Daily Mail CD in there. And we do indeed have a round brilliant. The U25W. A lot better than the later square type, in my humble opinion. But yeah, there we go. Right, we need a socket for the bottom of there, just to fetch the brilliant out. My ability to size nuts appears to have gone out of the window. It's 8mm. See how badly damaged it's been, if it's been damaged at all. I mean, I haven't plugged this in yet, but I do want to inspect it before we go mad and condemn it for something it's not. But yeah, I don't want to risk doing any further damage to it either. Okay, we need that plug out of there. Oh, come on. It's probably all been there for getting on for 20 odd years now. That's the power supply out. Another plug in there. Jam written on there for some reason. Right, I'm just going to pop that down out of the way. And let's inspect our power supply. 3 screws on the bottom. Now, this power supply can stay charged up, so be very wary when you're poking around inside them. There we go. We've got quite a coarse threaded cheese headed type of screw. Yeah, best beware with these things. And we've got to get it apart, and that can be a bit of a challenge as well sometimes. Because these grommets tend to stick in the holes and give you a bit of a hard time. Hey, we're in. There we go. Right, the bit we've got to be careful of are these 2 reservoir capacitors down here. They can retain a nasty surprise, so we want to try and avoid those. Common faults, the reefer, which as you can see is cracking up. That's a bit of an oddball, is the reefer on the U25, because some of them have got 4 pins on. But it's not difficult to get. It is still available. We've got some components there. Look like they've been very warm in their life. Indeed they have. But yeah, we just need to get this apart and recap it. Dare I say it? I dare. Because That's the root cause of our problem. Of course, it is a bit of a low bake oven, this power supply. I am just going to move around to the diode mode here and just beep our outputs. Good. That's good. That one is not. And I've had this several times now, where one of these output tantalum capacitors fails short circuit. And if you just look there, you can see that one's got a very unpleasant colour where it has failed short circuit. So we need to replace that and replace all the electrolytics. This thing, you know, it's had a tough life, bless it. So gingerly, so I don't get a belt, remove these 3 plastic screws. The other thing we'll need to do is make sure we've not got a short circuit chopper device, because if we have, it's the controller IC that's failed and you can't get them. So that'll be game over for this one if it is. In which case we can consider unbrillianting it. There's a former video here somewhere about the power supply I designed and built to replace these things when they fail. 3 standoffs out the way. Being careful, just in case it's been on recently and it's a bit zappy. So there are bleeder resistors on there, but if they failed open, we're on a hiding it to nothing. So I will just have a little measure on there. Nothing at all. Dead as a doornail. That's good. Right, this is the chopper transistor over here. I just want to give that a quick measure to make sure it's not failed short circuit. Nope, it's fine. Excellent. And the other thing is just across the mains input as well, see if that's failed short. Nope. You can see where the heat from these larger resistors here has discoloured the board, and all that heat's just gone into it and spoilt our fun. So there is our, see, you've got 2 capacitors in there, X2 and Y, and you can see, yeah, it's just starting to craze up, and there's just no point in leaving that in there because it'll come back. Right, let's get a warm soldering iron and just desolder that. I'll resolder it before I attempt to get it out. This is 3 pins, that's it. I couldn't remember whether it was 3 or 4. It is a 3-pin device. There we go. You can just see on the surface there, it's just starting to craze. It's not got long left for this world, so we'll have a new one of those. And there's a couple of electrolytics on the bottom here. I'm going to measure these to see how they are. Now, because of the bleed resistor across them, I'm not sure whether my capacitor meter is going to give me a sensible result. That value of resistor there, you can see it there. It's R2 and R3. It is quite large because it's only got to discharge it slowly and also balance the voltage across it because it's a multi-voltage supply. But we'll just have a little look. 296.1, 0.22 of an ohm. I'm happy with that. 303.2 of an ohm, and they're supposed to be, they'll be 330, so one of them's a bit low actually, isn't it? In fact, they're both 10% low. Plus or minus 10%, am I happy? We'll see how it performs. I suspect there will be no issue at all with that. So we need 1 reefer. We've got 2 electrolytics on the top here and a tant. So yeah, 1, 2, 1, 2, 4 electrolytics and that tantalum capacitor. Right, let's get on it. Right, don't know what's wrong with everybody at the minute, but parts are taking ages to get here, including the weird 3-legged reefer and our 3 surface mount TANs. So let's get on to changing those. Over onto the other board, and we've got our TANs to change. And one thing I'm going to do this time is just mark up the direction of the negative pole on each one, because I think last time I got it wrong. And a TANT will not survive reverse polarity for any length of time whatsoever. I know only one's failed, but I am going to change all 3. They've all been in there the same length of time. They're all going to be much of a muchness. There you go, appear to have got those on straighter than Linn did. Right, pot of parts from earlier. Now, to get this lined back up so we can get it all back together. Yeah, I've got a sneaking suspicion you can't, this has got to go in the right way round. Oh, there's my bit of blue tack. One of the pillars is slightly offset. Do you know what? It works a lot better if you put this one on the bottom. And plug it in, see if it's a runner. Just going to have a quick check round, see if we've got any unpleasantries in here, such as Elna caps, but we seem to be all good. I'm going to need an IEC lead. Plug a bit of audio into the workshop amplifier. And we'll switch on and see what happens. Precisely nothing. That's disappointing. Let's just make sure that the fuse hasn't blown on the input. And Linn thoughtfully put the socket in sort of upside down to convention. They're not the only ones guilty of it, but it does mean the fuse falls out. That's super disappointing. Right, sanity check. That my mains lead is actually still providing power. Meter to volts AC. 230 of our fine English volts. And we are still utterly dead. Very disappointing. Not entirely unsurprising. So it's back in bits, and see what we've missed. Just before I do that, is a meter in shot, sort of, bit glary. There you go. Volts DC. There's a ground point on here somewhere, normally marked up as such. That one will do. Just see what we've got on the brilliant. Precious little, precious little, precious little, precious little, precious little. Yeah, so something is not right, is it? Let's just disconnect that from there and see if we get any volts on it now. It will run quite happily off load. Now, memory serves, that centre pin there is ground on this 3 on this side. No, it is still the brilliant that's at fault. Yeah. Okay. Now, I'm going to switch this off and go for a cup of tea, because my bet in is those horrible big electrolytics in there are going to be unpleasantly charged and a little bit zappy. So I'm going to come back to this in about 10 minutes time. Fresh brew in hand. So, couldn't help myself, I've already got it apart. So, I can't measure. I had a poke round with the meter, see if anything was going to be a bit zappy. So, with the power supply, you can see there's a cutout there. That's the isolation barrier. So, anything this side of this top board has the potential to be a bit zappy. So, tread carefully. Now what I want to do is work out where the startup supply is, and thankfully there's a schematic available for this, not so the later square brilliant, which is you're on your own with that one, as we've seen previously where we've had to unbrilliant things. So yeah, I just want to just take that top board away there. Please don't bite me. I also want to check, because we've had one of these, that capacitor that failed short on the output, that tant, I just want to check the rectifier hasn't gone short, because that will stop play as well. So right, let's just splay things out a bit. You can see the cornucopia of rectifiers on the secondary here. I'm going to put meter to diode. And we're just going to have a buzz around these. One is a bridge and one is just 2 rectifiers. That's okay. You'll soon find if any of them are short. That's okay. That's okay. It's okay. That's okay. Right. So probably none of those. Did wonder that this had been a bit warm at some stage, but it looks all right. What value is it? 47 ohms. Oh. 47 ohms, don't know what it is, but yeah, okay. So we are not starting up. I want to make sure my work is correct. I don't put anything in backwards, which would have been a soppy mistake to make. We've got a couple of rectifiers over here to check. That's all good. It would be if I had the meter set to the correct. Yeah, ooh, that was a bit low. That's a bit reading the same both ways. What's it got across it? Transformer winding, so yeah, it's probably fine. We shall come back to that. So we have got a dead power supply. Now, as I mentioned previously, we can just pop some mains into there, isolated, please, and see what's going on. But because I've got the schematic, I can find the startup resistor chain, which is a chain of resistors, comes from the rectified mains. We've got mains coming in, charging up these two big capacitors. That charges up, and then we need a low voltage supply that powers our switch mode controller I see here. And if that's not working, that thing will never start up. So let me just look at the schematic for a second, and yeah, we'll find out what that is. Now, whilst Doz is looking at that schematic, I'm going to point out that there's no startup resistor chain on this actual power supply. It's derived from a single resistor, quite a watty thing, and it's switched with a FET, which is rather unusual. Now, the problem we're currently experiencing is actually partially down to the IEC lead on the bench, which is of dubious quality and doesn't make decent connection. So what actually happened is I plugged it in, the power supply started up quite correctly, then the mains lead failed, taking mains away, the Brilliant switched itself off, and then never recovered. Now, if I was to plug this power supply in now, I'd find it would start up and run fine. But it has got another problem, and it took hours to find. Let's rejoin Doz, where he puts the thing together and it works again. Right, it's the following day. I put Rio in last night to give that a listen. Fine album. And got about halfway through, and then I thought I'd just power cycle it. Power cycled it. Sure enough, it was dead. Now, what I think is going on, I think we've got a fault on the main board here. And just looking around, and I spotted some sort of marks on the PCB down here, and I just wonder whether we've got some capacitor problems. I did put my hands on these caps, and these regulators were not hot, but I swear that the capacitors were warmer than the regulators were, which probably means they're leaking like a sieve. So sure enough, if you let the power supply discharge and fire it up, we fired it up without load. I know that's a risky thing to do, but it did fire up fine. So it's now the following day, so everything is stone cold. I'm powered from my lead there, so I'm just going to put power on, and let's see if it comes back up. No, it hasn't done. Interesting. Right, what voltages have I got over here again? Very little. Very little. I don't know whether I've got a fault in the power supply or in the main board. So now this power supply is tripped, it won't come on again until it's sort of fully discharged itself. So yeah, what I was going to do is use the thermal camera and see if we got anything getting warm over here. I suppose what I could do, just disconnect from there and have a little measure on the board and see if we've got anything a little bit low resistance. You see, that's millions of ohms. 600k, so in that. 500k. We got on these end too. It's charging up a cap, isn't it? 600 ohms. 47k, yeah. You see, this is the problem with this job. I think what I need to do, just wait till that power supply discharges, stick a load on it, and just see if we can get, you know, any meaningful voltage out here. I just want to load down the higher rails there with some watty resistors, and let's see if the power supply starts up and starts up reliably, and if it does, then we can go from there and maybe locate the fault on here. I really don't know which way this is going to go at the moment. We need more information, so we need to obtain it. So this is just a personal vendetta against it at this point. Right, let me find some resistors and make up a bit of a load. Right, this has been running for about 25 minutes now. I just put it on the lid of the power supply because it was getting a bit toasty against the bench there. Still running fine. 25 volts, so things have crept up a bit, but those resistors might have drifted a bit, just to give you some idea of how hot it is. Let's have a look on the old thermal camera. Oh yeah, it's that's 135 degrees, those resistors, so yeah. That's warm enough. Right, what I'm going to do is I'm going to power down, and then I'm going to see if it now will restart, because that's where it all went wrong yesterday. So power's off. Let's just make sure our volts have disappeared. They have. Right, power going back on. Let's see if it's started up again. No. Well, that's thrown me. So it is a fault somewhere on the Brilliant that's stopping it from starting up. Right. I didn't expect that, if I'm honest. That is, well, it is news. Pop that down there so I can get on it a bit. I ought to make a little test box up, really. I do enough of these damn things. No, that's dead. Right, okay. We have got a further fault in the Brilliant. Right, okay. I don't want to grab hold of that, really. That's going to be quite warm for a minute or two. There we go. It's not too bad there. Yeah, that's interesting. I didn't think that was going to be our problem. Now, the one thing I haven't considered, really, because it doesn't happen very often, is what happens if one of those capacitors that I've fitted isn't up to the job. Stranger things have happened, so I reckon I need to go back round and measure the capacitors that I fitted right, let's add another 25 odd minutes running, probably a bit longer than this time. Still running fine. Let's have a quick look with the thermal camera just to see what we can see. Nothing's getting particularly warm on that board. Yeah, we've got some heat going on here. But not unexpected. Those two caps are cool though. Right, power going off. Just check our rails have vanished. They have. Power going on. Is it going to have come back up? No. Wow. Okay, we've still got a fault. So if it's temperature related, maybe we should have a squib round with a bit of freezer spray. Where to start really? Let's start with that chip there. Give that a little squib of freezer spray. See if it comes back up now. Okay, power is on. Nope, still dead. Okay. Righty. So, squib around those caps there as well. Want to be a little bit careful on account of the zappiness. Okay. Power is on. Dead. Right, I need to get to the other side of that board where the controller chip is, don't I? Sketchy. Right, let's give the controller chip a little bit of coolness. See if it starts up now. No. What is going on? What is going on? There's a Zener and a few other bits up there. Or a diode of some description. Some diodes on there as well, haven't we? Let's just give those a bit of a squib. And we're back up and running. Okay. So could be some. It's going to be. If you get a thermal component, it's generally a semiconductor or a capacitor. Capacitors can be really badly thermal. But semiconductor or yeah. So whilst Doz bangs on about stuff being thermal and still scratching his head, I'm going to point out that there's nothing thermally wrong on that PCB. This is a real head scratcher.
3,000 years later.
Right, I've been doing a lot of testing. Just to give you some idea, that fluke was just for measuring things. That's hooked permanently to the output on the dummy load, and this was across the startup voltage, and that's what gave me the clue. Now, for some bizarre reason, I think to keep maybe a bit of heat dissipation down, the startup voltage, which is derived from this R12 and is about 9 volts, it's switched on via this transistor being off and this FET being switched on. So this transistor switches this FET on, which allows 9 volts to run down one of these wires here, and then start the switch mode oscillator running. All good. Now, that's fine the first time you run it. And if you just run it for a second and power cycle it, output disappears and it never comes back. And that's because this transistor is being switched on at this point, which has switched the FET off and the 9-volt supply goes missing. But if you leave it for about 10 minutes, it does start up. And that got me to thinking, so I'm looking for the time constant which is controlling this, and it is in this circuit here and under here. And the time constant is controlled by that capacitor that we have replaced and a discharge resistor across it, which is R5 here. A little surface mounted resistor, clearly marked 100k. Yeah, I think this power supply has always been like that, because on every schematic I can find for this power supply, R5 is listed as being 10k. Therefore, our time constant is going to be 10 times as long, which is huge. I reckon R5 should be 10k. Everything is working as it should be. I have got some questions. There's a transistor here missing, which is Q1, not fitted in this design, and it is just to provide a shutdown voltage, which is actually not required because of the action of R5, which I think is the wrong part. I reckon this power supply has always been faulty. I mean, it does happen. Somebody, you know, takes one look at a reel, 10k, 100k, it's 103 or 104 written on the resistor, and they've just got it wrong. I will just measure it because I couldn't really measure it in circuit. Let me just see if I can get on there. 100k. Right, I want a 10k resistor then. Right, just clean up that. I don't need the magnifying glass for that. I can just about see it with my magnifiers on. Don't need the microscope. That's what I meant to say. I can just about see this, so should be okay, I think. The bench is a mess. I can't find anything. Where are the tweezers gone? There they are. Right. What have I got? Metro hit's gone on. That's my voltage from my... So that's output from the supply. That's not connected to anything at the moment. This is output from the startup rail. Right, going on. I expect it to come on straight. Now I haven't put the capacitor back in. Oh, I've just charged it all back up again, haven't I? Tricky. Just see if I can tack him back in from the top side. That looks good. Okay, right. Power going on. 25 volts. Minus 13 volts. It's actually plus 13 volts. I've got the leads around the wrong way. That is correct. Switch that off. Wait till that disappears. Switch back on again. 25 volts. Off. 24 volts. Off. I don't know what to say. That power supply has had a fault on it ever since it left the factory. Right, let's get it all back together once again. Right, wow, I was all for giving up with this thing, but now we've sorted out that power supply, and I think we've learned a lesson there, is never trust the person that's been there before you, even if they were the manufacturers. Right, it's amazing it's, you know, gone for this long. Next thing to do is I'm going to sort out the transport. I've already removed the screws from the bottom. There's just 4 screws, quite a short M4, maybe M5 kind of thing there, and a washer that goes with it. 4 of those, and that just makes the sled move about. You don't have to take the drawer front off or anything. So let's just pop the wiring out. I don't think it's possible to get these around the wrong way. We'll just check the connectors are different sizes. They are not. I am therefore just going to mark that up with a Sharpie so we know that that one goes in that connector there. Not that we can get that wrong, but I don't think the leads are long enough. But let's not be at home to Mr. Cock-up this late in the game. I've refrained from putting the power supply back in just so I can easily manoeuvre the transport out of the way and retrieve my copy of Rio and find out why the sled isn't any good. So what drives it? There's a rubber belt in there, and yet the gear up and down seems to be working adequately. Spin motor there. This presumably, no, there's the, so we've clearly got 2 belts. Yeah, we have, oh, it's a massive belt system on the right here. Is 1, 2 belts in there and a drive cord, so I suspect it's one of those 2. The actual movement where the disc is clamped appears to be working fine. I take it that's that motor there. So yeah, right. How am I going to get in there and get those belts out? Can we get down the side? No, not really. So it's going to be removal of stuff. Yeah, we've got to, because we can't pass the belts past these screws that secure the pulleys in. I hope they don't just pop all the way out. That'll be horrible. Can we just slide that out? No, we can't, because the disc is clamped. Oh, right, okay. Let's just put some power on that motor. I'm just going to disconnect it because that motor will be controlled by a bidirectional driver, and I don't want to put power into it and damage it. So a bit of lab power supply. It's 5 volts there. Oh, should be enough maybe. Let's just hook up some power, and that's the wrong way, isn't it? Maybe not. Maybe we need a little more current there. That's 9 volts. That sounds like that belt is slipping as well. Ah, have we released the clamp? No, we haven't. Okay. Perhaps it doesn't like being upside down. I think we don't want a set of belts, aren't we? No. Okay, I give up. I'm going to put it back in the disc player, and we're going to go from there. No, something is stuck. Well, that's a pain, isn't it? So, as we were, and we'll just have to do some disassembly to release my disc and get the thing out. What a pain. Nothing about this job has been anything approaching easy. Right, I'm going to take that top off first so I can get my disc back. Clamp, tiny little short M3. Joy, that one's seized up. That one's coming out. Get a little bit of heat in there. And maybe a bit of cold as well then. There she goes. This keeps fighting me like this. We're going to fall out. Right, I have my Rio disc back. Results. So now, hopefully I can get to all of the belts. I can't because it's locked in place. What's locking it in place? The fact that that's still in the upward position. Oh dear. I wonder if we can... Now we've removed the clamp, which is obviously slightly magnetic. Maybe we've got enough for this to operate now. Fighting me every step of the way. I need to change the belt. The belt is in there. We need to remove the tray to change the belt. We can't remove the tray because the belt's slipping and doesn't drop the carriage out of the way. Hey. Can we manually lower it down? Oh, we can, look. That's better. Okay. So obviously that belt's driving that worm that's just turning that. Can we get enough clearance there now? We can. Hallelujah. Right. Okay. So what can I get at now? Where's my belt? Belt's right under there. Really want to take this out the way if I can. So what have we got? We've got 2 screws here holding this linear rail in place. And that, but if I get that out of there, it should all just come out, shouldn't it? So let's do that. Okay. Now if I slot that out of there, I can't do that because it's attached to the drive cord, which pulls it out of the way. Just undo those 2 then, slide it off that way. Right, put the linear rail back in. Two out of here then, shall we? Hurrah! Substantial thing, isn't it, really? Wanted to be for the money. Okay. Can I see what I'm doing now? I don't think I can. Let me just see if I can persuade that motor to move out any more, and then remove the bracket that holds that up, and then take it out as one or 2 pieces. Yeah, there we go. So if I take it too far, yeah, that's now out of the way a bit, and I can undo the screws and remove the worm drive assembly as one thing, I think. Yes. There's a 3rd screw right under there that I can't get to. Don't make me remove everything, surely. Okay. Okay. Wow. It's a thing, isn't it? And there's our belt. and it's horrible. Yep, that's no longer much in the way of use, is it? Right, let's find a new one. Cool, bob on. Right, new belt going on. Okay, I suppose I better just check that sort of works reliably now. Pretty good. Happy with that. Right. Okay. Switch the power supply off. Don't need that again. So now we're back to dealing with the sled belts. And this isn't a cover. This is just all one thing. And you can see that pulley goes through there. So this board is going to have to come off to allow access to the belts. What madness is this? Wow, okay. Because if I take that off there, oh, I might just be able to slip the belts through. Oh, it's a conceptual thing, isn't it? Let's just take these screws out of here and see what happens. M3 again. A little bit longer this time. If this goes for tang now, I should be very displeased. That one's completely turning, which bothers me. It's turning on the other side, so I'm going to need a two-pronged attack here. Hopefully that'll get on there just enough to hold it in place while this one comes undone. I think it does. Hopefully the right screw is undoing, otherwise this is going to be painful. Don't think it is, I think it's forcing the other one out. Oh, it is. Yeah, it is. Okay, well, it is what it is, isn't it? If I've got to undo this one as well, I've got to undo this one as well. That leaves that pulley somewhat unsupported. Unless I put the screw back in that side, which I could do, couldn't I? What a horrible design. It was never designed to be repaired, was it? Right. I think I can now ease the belts out through there. But what a nasty, horrible design, isn't it? That was never made to be serviced at all. Time for a cup of tea. Right, I'm glad I've had a cup of tea because it's cleared my head a bit, and I've realised, let's zoom in a bit in manual here, so we can try and see what's going on. So, can you see down the back of that slot? Not really. Right, what happens is this motor here drives this pulley here, which then drives this pulley here, which then drives a cord which is attached to that brass thing there, which pushes the sled out, pushes the, you know, the carriage out. Now the problem is all the belts are on that side. Now I can get the one off by hooking this one here between here and here, by hooking that belt out, that belt off, and then taking it out, and I'll get away with it. What I can't do is get that other belt out, because what I need to do is basically I need to put those two screws back in and get these two out here and work that way. So yeah, we're putting the screws back in again, everyone. Isn't that just lovely? What just a horrible, horrible design. So I'm just hoping that by holding, the trouble is as I unscrew one, I'm going to be unscrewing the other, I think, because of the way the threads work. Let's try our level best to screw that back in. Try and get the other one out. If not, I think I can loosen both up and then try and grip the shaft that's in between holding the pulley and getting it out that way. But, oh, it's just horrible. Alright, that's worked. I've got that one out. Right, so that allows me, yeah, to get that belt out of there. Do I want to do that yet? Probably not. Let's just see if we can get this other screw out of here. I think this screwdriver in through that slot, quite, that one's not long enough. It's all on an unpleasant angle, isn't it? Oh, I need to put the screw back in first. Really isn't made to be repaired at all. Oh yes, I got away with it. Right, okay, that's better. It's not ideal, but it is better. Now, if I undo that one, it would allow me to get the whole thing out. And will it happen? Yes, it will. That might just buy me a little more room that I can get in there. Yeah, would you look at that? And there's the belts. Right, that's one. And that's two, and they are absolutely shot baggy as hell. So, okay. Did leave this bag out because these look eminently suitable. And what have we got? Have we got stuff that will do here? I'm in the way of myself here. Not easy. That wasn't too bad in the end, was it? Just getting the right screws out, knowing the order of assembly. So those are shot. New belt on there, new belts in there. Right, smash it back together and see if it runs all right. Before I put that cover back on, I can still see some muck on that lens, so I'm just going to give that another bit of a birthday. Yeah, it looks better. Okay, on with the top, slightly offset because it's got the gear in one side, so the linear bearing type arrangement, so that can go in like that. Right, put it back together, see if it works. Where does that go? Oh, that's the cross motor one, isn't it? Oh, there's always going to be one you leave out, isn't there? Yeah, look at that. What a bit of disaster. Power going on. Oh, Oh! Oh! That's opening and closing, an absolute treat now. Right, let's get some audio out of it and see how it plays. Yep, it's playing just fine. Right, I'm just going to turn that down for a second before we get hit with copyright, because that's Duran Duran and I'm sure they'll want paying. But yeah, we appear to have a running CD player. Obviously I've got to bolt the power supply back in, bolt that back in, but I think I'm calling this done. I'm just going to leave it on test for a bit and pronounce this one done. Thank goodness for that. And there you have it, the Linn Karik from January 95, this one. But yeah, clearly hasn't worked properly since the day it left the factory. What a fault to want to find. And yeah, it was originally going to be just a quick win video on how to do a U25W brilliant power supply. But what a challenge that's been. And the belts and everything else, it's now playing nicely. Thank goodness for that. Anyway, thank you very much for watching. Click like, subscribe, do all that rubbish, and I'll see you really soon here on Doz's Television Workshop. Cheers now. Bye.
With a gentle hand, he brings them back in line. Every twist and turn makes the magic shine. Cathodes and the crackle of the tubes amidst the dust. They play nostalgic tunes, solder smoke, and the faint aroma of time in each repair. An art that's so prime. In Dar's each shop, where wires twist and spark, fix the picture, bring back color in the dark. Screens that buzz, it's magic on display. Old TVs revived in a brand new way. Circuit woes, but we're getting closer. Neon signs, they guide you to the door. Tubes and screens like you've never seen before. Pulses hum as sparks begin to fly. In this tiny shop, dreams are set too high. In Darcy's shop, with a touch of love, your picture's clear and true. In Darcy's hands, pixels flicker back to life and stand. Microchips and vintage heart in a world of screens playing their parts. Circuit boards with stories to untangle. Every wire a promise as an angle. As he bends the light through the lens, creating onyx nights. Oscillators, creating sonic waves, bringing back the charm of retro days. Capacitors and resistors. In Dozzy's touch, there's no misfire. Transistors dance to the rhythm of repair. Through the glow, feels like magic fills the air. Voltage pulses, the tune's melodic run. A symphony of sparks, where the work is never done. In